recording started.
So make sure that you guys going through the chapter review questions. That's going to be the most important one this week probably, to make sure that you have chapter review questions completed multiple times for chapter 3 and chapter 4. Okay? Make sure that you are using your compiler to compile all the sample code in each one of the chapters, and make sure that you understand every single line of code, what it does. If not, bring in questions for those exercises or for those sample code. Okay? So in chapter 4, what we're talking about is the selection statements. What we used to write about in chapter 1b was selection is a diamond shape, right? So selection is a diamond shape where we make a decision. So we don't know how to make decision yet. That's what we're going to talk about in this chapter. Okay. So when we have a selection, we can either have a true answer or a false when we're referring to the logic within this diamond shape. And at that point, we're either going to complete something on the true side of this selection statement or on the false side. So if it's false, it's A. If it's true, it is B. Now eventually, both of these statements come together and continue on with the code. Okay? So regardless if the question was resulting to true or false, regardless of if A or B was executed, C will always be executed. So if you look at this whole structure, okay, if you look at this structure right here, if you kind of zoom out, okay, then you would see this we might call that I, or that's what we called in previous chapters, right? So we might refer to that I, and then we execute C. Okay? The difference here is not I, it is a more structured, complex box. It's not just a simple box. But C has nothing to do with the selection statement. So C just becomes another sequential box in this two-sequence structure. Okay, so we have I and C, where I is a selection statement. So that's going to be important to kind of understand for us as we move forward. Okay, so if we have a logical statement right here, okay, so here we have some kind of a logic. We're going to have to talk about that and what is that Boolean data type, Boolean expression that we're going to be basically building. The Boolean means the answer is either true or false, okay, or the state is either true or false, okay. And now we're going to have to be careful what is it that we want to accomplish. So if it's still going to be structured code if we write something like this. Okay, so let's say if it's true, it's A. If it's false, it's B, C, and D. So what does that look like as far as the code is concerned? When we were talking about a sequential code, a sequential statements, let's say we have A, B, and C. Okay? As we're executing this code, A, B, and C, they're all going to be executed. So they're all going to be considered and launched as the code progresses. Now, when we're talking about selection statement, we have to be careful, because, and that's why you have to take, that's why you had that exercise on what is the proper input in order to test a code. Remember on the art students and chemistry students? The reason for that was that is the test data that we're going to send into this code. And if we do not have the proper data to test our code with, okay, you might only testing this path, which is A and D. If you do not have the proper code, you might never test the false side of this selection statement. So that's why when we looked at the art students and said, okay, is this a proper data to test the code to show the number of art students? Well, we don't know what the art students was because the input had no art students in it. So if we don't have art students, we cannot figure out if the code actually displays those. So that's why that exercise was important, even though we did not know how to program. You have to realize that the input is important, because after you write the code, you have to test if your code functions properly. But the main point here is that if we have a selection statement, okay, we have two different paths that we can follow. Okay, so if the logic, let's just write, if the logic is true, then what's going to be executed? We're going to execute A and then D only. Now, if the logic is false, then what's going to happen with this code? We're only going to execute B, C, and D. So you can see, regardless if the logic was true or false, D will always execute, because we show that in the flowchart after A, B, and C structure, the selection statement comes together and continues on. Okay, so it's going to be very important to look at it from that point of view. And now we are making sense out of all of the flowchart symbols and the pseudocode that we wrote in chapter 1b. Okay, so make sure that you go through these PowerPoints and the slides, and make sure that you read the chapter, run every single sample code, and that's how it's going to make more sense. So don't rush to the assignment right away, because it's not going to make sense. It's going to confuse you. Okay, so then we're going to look at different structures. So many times when you look at the flowchart symbols will not change, but the keywords that we're going to use will change. So the switch statement is still an if statement, but in a simplified version. And then we're going to start looking into input validation. Okay, so we're going to be looking at the assert function and its functionality, or why would we use that. Okay, so control structure, a computer can produce a proceed in sequence, right? So that's where we had our basic code of, let's say, A, then B, then C, then D. We can have a selective, where we have a structure and we either go, let's say, A, and then we go B, and then we go C, and then we go D. Okay, so that was the selection. Now then we have repetition. So if we have repetition, we're still going to have to make the same Boolean decision. Okay, But then we might say A, B, C, oops, that's D, okay, and we go back to the loop. All that's going to happen while the loop is true, and then when the Boolean logic resolves to false, then we exit out of that. Or we can proceed with the computer code by calling a function. Okay. So now if you're calling a function, that means you have a code, and that code going to have a function, and maybe it's going to be POW, and that is a call to another function, another flowchart that somebody else wrote, that will eventually return back to our code the result. So we don't have to write the code for it, we just need to know how to use somebody else's function. And that's also part of the branching. So the two most common structures are selection and repetition. Okay. So again, you have all these shapes. So at this point, try to be kind of generic. Look at the concept of what these shapes mean. Okay. And as we're moving further into code, actual coding, still kind of visualize all of these shapes. Okay. So execution of selection or repetition requires execution of a logical expression. Now the logical expression will evaluate to either true or false. So computers don't understand maybe. They only go either or, left or right. Okay? So the question might be, is 8 greater than 3? And then the answer is true. So that means the code will branch the true side of our flowchart. Relational operators, these are very important. Make sure that you look at this table. Okay, that's going to be the trickiest one right here. Okay, this is not an assignment operator. So make sure that they're going to be different. You see the difference between the assignment operator, okay, and then you have the relational operator, the equal, and there is no space between them. Okay, so later on when you say if x equal 5, then do something, or if say if x equal 5, then do something. This is not the same thing. Okay, so this is not the same thing. That is an assignment operator. So when you assign a value, you just are saying, did the assignment successfully complete? Yes, it did complete successfully. But that's not what you want to do. What you want to do is, if x is, let's say, 15, x is 15, and then you want to compare that 15 to 5, then what you're asking is 15 equals to 5, and that's gonna be a false statement. So if you read the book, even the author will point out that a lot of people make this mistake, and I've seen it in every single one of my classes. And you guys gonna make that mistake, and right now you're saying that it's simple, it's obvious, I'm not gonna make that mistake, and trust me, you will. Okay, so pay attention to that. So conditional statements only execute if certain conditions are met. Condition represented by a logical expression that evaluates to a Boolean value. So logical expressions evaluate the Boolean values. A relational operator allows for comparison, require 2 operands. So something on both sides of the operator. and they will evaluate the true or false. Okay. So this is what you would do in a math class, so I don't think it's going to be very complicated for anybody to understand that, especially if you look at it as actual values. Okay, so don't automatically, I don't know, jump to, let's say, x equals 8 and y equals 15, and then you say x less than y. Okay, that's going to be the same thing as this expression right here. Okay, so you don't want to jump right to variables. If this is your first time programming, you might want to have this kind of examples. Okay, and that's going to be easy to maybe do in the code itself. Okay, so you can write a simple little application that will tell you all these results. Okay, so practice it that way, or just on a piece of paper. So how do we compare characters? Now remember that the characters are integral data types. So when we're looking at characters are really numbers. So when we say A, capital A is really 65, and it also equals to hex value. We always start hex value with a 0. Okay, hex value 41. So those are the numbers. So each ASCII characters, remember, you can look up the ASCII table for actual values, but you can actually compare characters because their characters are actual numbers, and we just display it for humans as characters. So because characters are numbers, now we can actually do the same type of comparisons just like with numbers. But we can represent them by the actual character. You do need to have the single quote around them. Otherwise, if we don't use the single quote, that's going to be considered as a variable. And that's not what we want. So in character comparison, we're really looking at the placement of a character in the alphabet. Remember, the ASCII code for the alphabet is a ordered set. So since they are ordered, capital A comes before capital B, and capital B comes before capital C. So that means we can see which one is less. Less means it comes before in the alphabet. So if it is true, then it comes back as 1. The result is 1, and otherwise it is 0 or false. So now, what is a one-way selection? The one-way selection does not have an else keyword in it. Remember from your pseudocode, what we learned in chapter 1a and 1b. If we only have the if statement, we do not have an else statement. That is a one-way selection. So the statement is executed if the value of the expression is true, only if it's true. And the statement is bypassed, or is not going to be considered, is not going to be processed if the expression is false. Now the expression is called a decision maker. Okay. So you have the decision maker, and the only way that we're going to execute the statement itself is if the expression returned a true statement. Otherwise, we don't do anything. It's just the code continues on. Now with a two-way selection, just like with the pseudocode, we have the if statement and the else statement. Now we do not have the keyword or the statement and if at the end, like we had it with the pseudocode. So the pseudocode is language independent. Now we are moving into language specific syntax. So C++ does not use the end if to show the end of the if statements or the if structure. Okay, so you're gonna see that when we're talking about an if statement in C++, okay, what we're gonna have is if, and then you use the parentheses, and let's say x greater than or equal to 15. Okay, and then we have a bracket, curly bracket, when we're gonna maybe execute a block, or let's just say cout a, else block statement, curly brackets. Okay. And here we might say cout b. Okay, so now what happens here? If the if statement returns true, everything in this bracket, okay, that is our basically the statement 1. Okay, statement 1 actually in C++ means anything between these two brackets. Okay, so that is what happens if the result of the expression is true. And when we have else, that's going to be the false block. Okay, so anything after the else keyword and between the two brackets is going to be executing. Okay, so that is statement 2. Okay, in the pseudocode you would have said if expression is true, then statement 1, else statement 2. Okay, and at the end we would say and if. So that would be the generic pseudocode. Now this is a kind of like a pseudocode for C++, okay, and this would be the actual code, how we are writing the code. So all three of these means the same thing. It's just the first two is more like, the first one is my generic statement. Okay, second one is the C++ generic statement pseudocode, and then the third one is the actual code. Okay, so that's how you would look. That's how the same thing would look like in pseudocode. I mean in flowchart, right? So you can visualize it more. So it depends what kind of a learner you are. You might be a visual learner, and you might not like something that's written in this fashion. In that case, you would make sure that you would have the flowchart, and then you can also see how the code's supposed to flow. And that's why you guys are required to turn in the flowchart and the pseudocode at this point. As you are working with both flowchart and pseudocode, you are going to be better at understanding which style of coding, which style of design would work for you, for your personality. And eventually you can drop either one of them. Okay. So so right now we're just getting used to designing the code before we actually start coding. Okay, so the Boolean data type, The Boolean data type is basically returns, or it's going to have two states, two values, 1 or 0. And it is an integer, so the integral data type. And that's what we use to manipulate logical expressions. So the Boolean data type actually has two states representing the 1 and true, and the 1 and 0, where 1 is true and 0 is false. Now Boolean, the B-O-O-L, true and false, are all reserved words, so you cannot use it for your variables or identifiers. Okay? So we can combine logical expressions, and Boolean operators can help you combine logical expressions. So these are not comparison operators, right? These are not comparing values. These are actual Boolean operators that are working with Boolean values. Now, what do you mean by Boolean values? Now here, when we say not, okay, so if something is true, with the not operator, it becomes false, right? So we're negating something. Now if you say and, now what is and? When we talk about and, so let's look at this. Let's say x and y. Now if x is 0, so y is 0, then the result is 0. If x is 1 and y is 0, result is 0. If x is 0, y is 1, result is 0. If x is 1 and y is 1, then the result is 1. Okay? So you're looking at two sides of the operators, the two operands, but the two operands are already Booleans, and that's why it's called a Boolean operator. The OR operator is the key right above your enter key. Okay, it looks like two vertical bars right on top of each other. Right? So if you have your enter key, yes, that's the one, right? So if you have the enter key, above your enter key, you have the backslash, and then above that you have the two lines. So you have to hold down the shift key to type that. Okay, good question. Okay, so x or y is 0, 0. If x is 0, y is 0, result is 0. If x is 1 and y is 0, then the result is 1. X is 0, y is 1, the result is 1. And x is 1, y is 1, the result is 1. So basically, you know, it's kind of like in everyday language, either or is true, or both is true, then the result is true. Okay? So that's what this Boolean operator is going to be working with. And they're going to be a little tricky to work with. And there's a really good example in this chapter for you guys. So make sure that you do go through this exercise right here, right? The actual example, the actual value, and the explanation. Okay, so it is really nice how the author lays down this chapter and make sure that you guys understand all the Boolean operators, one example at a time, okay, and gives you a very nice explanation. Okay, so here you can see that something needs to be evaluated, and then something else needs to be evaluated, those gonna be Boolean values, and then you're comparing. Then you're working with those two results. Okay. So is 14 greater than equal to 5? Well, that is true. Is A greater than B? What does that mean? A comes after B in the alphabet. No. A comes before in the alphabet, so this is false. But because we have the OR operator, okay, the result is true. The result is true because the first value was true, the second was value false, and the OR operator is still going to be true. Okay. And that brings up the whole question of our order of precedence. Right? So relational and logical operators are evaluated from left to right. Okay? So just like the way that we read it, here we evaluated it from the left, and then we evaluated the right. And if you have multiple Boolean operators, they're going to be also evaluated from left to right. Okay, so that's what the associativity means. And like with anything order of precedence related, a parentheses always override the default precedence. Okay. So you can see that we still have this regular operator precedence. So first of all, we have the unary operators, then we have the arithmetic operators, then we have the comparison operators, and then the Boolean operators, and finally we assign the value to something. Right? So that's why if you have something like x equals to -3 plus 2 and less than or equals to -5 minus 10, and maybe all this, or 1. Okay, so what's going to be the result of this? Well, the thing is that there's also a shortcut. Okay? Well, first of all, let's go through this. And unary operator, right? So the parentheses really comes way above all these. So we look at the parentheses. Parentheses are evaluated left to right as well. Okay? So you look at the outer parentheses right here. Okay? We don't go to the OR because that's going to be one of the last operators to evaluate. So you go inside the parentheses, and the parentheses you go left to right, and left to right you see another set of parentheses. In that case you have an expression. Okay, so first you see -3. Well, -3 is a unary operator, so it looks at it as, oh, okay, that's a minus value. Does 2 have a unary operator to it? No. So then it goes down and says, okay, but what is it that I need to do? Well, I need to add these together. Okay, so that's going to, the result is -1. Okay, and then you go to evaluate the next set of parentheses. Okay, again we go back to unary operator. Unary operator is right here from -5. Okay, and then we look at -10. Okay. We do the operation. The operation is going to be what, -15. Right? At that point, we are still inside the outer parentheses. So we need to look at if this is going to be a true or false, and the result of this. So now it's a binary operator, okay? But with the binary operator, we are looking at the comparison operators, okay? and the comparison operator will return an actual false value, right? Or false is also equals to 0. And at that point, now we are ready to compare the two values. So now what we're really comparing is 0 or 1. Okay? And 0 or 1 results in 1. Okay? So you go top down, one operator at a time, and then you have a result. Now, is there a shortcut that we could have figured this out way ahead of time? Well, if you look at all this, right, if you look at all this, it doesn't really matter what the result of that is. Why? Because at least one side of the OR operator is 1. So it cannot be false, it always going to be true. So we did not really have to go through all this. And computers actually do this kind of a shortcut when evaluating expressions. Okay. So make sure that you run the example 4-13 and play with that source code. Okay. Make sure you go through these examples, right? You have the expression, you have the value and the explanation. It's a very good exercise. You really have to go through that in order to understand this chapter. Okay. Very good examples, very good explanations. You just have to do this with a piece of paper and a pencil, and just go through these exercises. You know, cover up a value and explanation. Cover up one side and then work with the other side and use the book as a guide to double check if you got the same answer or not. Okay? And you can do it vice versa to make sure that you can actually create the expression on your own. Okay, so relational operators and the string type. So just make sure that you understand how do we compare characters, because a string is nothing but a collection of characters. So when we are comparing strings, we are comparing character by character, starting with the first character, and you compare it one character at a time, and comparison continues until either a mismatch is found or all characters are found equal. Now, if two strings are different lengths and they are compared, the comparison is equal to the last character of the shorter string. So the shorter string is less than the larger string. It's kind of like, think about like if you would file documents, or if you would work in the library, how would you put the books on the shelves? Well, you would think about the same exact way. The shorter words would go first before the longer words that start with the same shorter word, right? Anything starts with an A would come before B. So computers work exactly the same way. So make sure that you go through this exercise. This is another really good exercise with very nice examples and explanation. Okay, again, do the same thing. Cover up one half, and then make sure that you come up with the same answer. Okay. So in this chapter, you have a lot of really good examples. And if you don't want to, you don't really have to use the compiler. You can do all this on a piece of paper without using the compiler. Now, those of you that are more advanced, make sure that you would type this into the compiler, create a simple example project, and actually run this code and see how it actually works. Okay. So when we have a multiple line of statements, okay, this is where it becomes important to really look at the flow chart again, right? So we have the expression, Right? So if you see this multiple line of statements, that's what we did in the flow chart when we call these, let's say, the A block and the B block and the C block. Okay? That just means that not just one single statement needs to be executed, but a block of statements needs to be executed. Okay, so now this is the actual syntax, right? So you have your expression. This is your expression right here. Now what happens if this expression returns true? So let's say age, somewhere before all this, we had age equals 25. Okay? Now you have a variable, and the variable needs to be compared. And because the result is true, only this portion will be executed. So this is the execution portion. Okay? So what happens when we get to this point? When we say eligible to a vote, no longer a minor. Okay? When we reach this block right here, what we do is we jump after the else statement. We do not execute anything in the else statement. Now what if we had, let's say, age 05? Then the expression looks at 5 is greater than 18. No, well, 5 is not greater than 18, so that's false. So in that case, what happens? Okay, let me change color here. Okay, in that case, this code actually jumps down to the else statement, which is the false statement, and anything in between these curly brackets gonna be executed. So now the only thing that you're gonna be seeing is not eligible to vote, still a minor. Okay, so the true block is gonna be skipped over. The multiple selection statements is called nested if. Nesting is one control statement is located within another. An else is associated with the most recent if that has not been paired with an else. Okay. So in this case, you can see that we have the if statement. Okay. If it's true, then your grade is A. Else, so that means if statement, the first if statement was false, so then you jump down over here, and then you have another comparison. So you compare the score to 80. Now if that is true, only the grade is B executed. And if that's the case, then you jump after the else statement. Nothing else is going to be executed. Okay. Now if a score is not greater than or equal to 80, then you jump over the statements and you go to the next comparison. So you have a logical decision to make, and another logical decision to make, and another logical decision to make. And then you're figuring out if its score is greater than or equal to 90. And then you're figuring out if it's greater than or equal to 80. If it's greater than or equal to 70. Okay? So it was false for the 90. It was false for the 80. If it's false for the 70, then you're comparing it to 60. Now if it's false for 60, then the only thing that you have to have is an output statement. Right? But if it was true, then you had an output statement. Okay? and that was output just for if you had 90. Now if you had 80, okay, so this was A, this was B, this output is C, this output is D, okay, and all of that flows into this flow chart. Okay, so now you can see the score is coming into the structure. So if score is greater than or equal to 90, then only A gonna be executed, and then everything else is going to be skipped. So that's what the flow chart would look like. So in this case, you are comparing months. Right? So month has to be an integral data type. So if this would be an actual code that if you want to type it in, right, then you would say int month, and let's say you assigning month number 5 to that. Okay. Now you see, you need to be careful. That's what I was talking about. You see this? This is the assignment operator. What that does is stores 5 in the variable month. Now when we are comparing it, now we're saying, is month equal to 1? No. Is month equal to 2? No. Is month equal to 3? No. Is month equal to 4? No. Is month equal to 5? Yes. Okay. So we jump right here. The code actually will jump right there. Okay. After that, you jump to the statement. And when the statement is gone, or you displayed may, then you jump out of the structure. So only one line of code, line number 10, is executed in this case. Okay. Now, what does that? Why is this different right here? Okay. Now here, if you want to look at this, okay, you make a decision, okay. And you keep making decisions. But these decisions don't rely on each other. 1, 2, 3, 4, 5, 6, right? And with any one of these decisions, we have an output okay, so we have the output. Okay, almost looks the same. It's pretty ugly, but anyway. So you can see that all of this is kind of independent. These are independent one-way selection statements. And if month 6 is false, we do not display anything. Okay? So it's not the same thing as we had before with this. Okay? These are independent statements, not relating on each other. So we have basically 6 one-way selections, 6 independent one-way selections. Okay. Short circuit, that's why you need to understand the Boolean logic. Okay. So we talked about the or and the and statements, right? So if we have or gonna be 0, 0 is 0, 0, 1 is 1, 1, 0 is 1, 1, 1 is 1. We have the end. 0, 0 is 0, 0, 1 is 0, 1, 0 is 0, 1, 1 is 1. Okay? Now here you can see that if any one of, when there's an AND Boolean logic, okay? If the system reads a 0 on the left-hand side, remember, Boolean expressions are evaluated from left to right. So if the left side is 0, then what's going to be the result? It's going to be 0, regardless of what the right side is. So you don't have to, right? You do not have to figure out if what is the right-hand side of this expression is. Okay, so you can make a decision. You see, as soon as you see that, let's say grade here is B, okay, that's false. If once the left side is false, then the whole expression is going to be false. You do not have to figure out what's x great if x is greater than or equal to 7. You don't have to do that. Now what about or? Now you can see with or, as soon as the left-hand side is 1, the left-hand side is true. What does that mean? At least one side is true. So if at least one side is true, does it matter what the other side is? It doesn't. It doesn't, because the result is going to be true. So you don't have to code this. The system just automatically works faster with it's a built-in shortcut that you can make a determination just by evaluating Boolean expressions. Okay, and then the floating point numbers, that's going to be something that you have to really think about. The floating point values, the system does not store 1 as 1, so it's going to have to, with numbers like this, when you can see that this is an estimate of 1, so computers have to round off values. You don't have that problem with integers. As soon as you're working with floating point values, you don't really want to compare the values themselves, but what you do is you're comparing the value up to a certain tolerance. Okay, so that's why you have this tolerance. Up to a certain tolerance, you accept the value, otherwise you reject it. Now in order to do that, because we don't know if x or y is larger, when we subtract the two just to get the tolerance, right, the difference. Because of that, we're using somebody else's function, and this is the function call. Okay, that's your function call. It is a floating point absolute value. So this way you don't have to figure out if x or y is larger. You just subtract the two from each other. It doesn't matter if it's positive or negative, the result. You're going to send it to this function, and this function will return the difference as a positive value. Now you can compare the difference of the two positive values and then see if that is a true or false result. Okay? So just the only thing that you need to remember is that with floating point values, computers are rounding the values. You cannot just compare the values. You need to subtract two values, take the absolute value of the result, and then compare it to a tolerance. Okay. But anyway, so I think there should be enough for one day. Okay. So we'll finish it up on Wednesday, and by Wednesday midnight, you guys have to complete the next test. So make sure that you read ahead. Okay. Do some of the exercises in the book. Okay. And bring some questions for Wednesday or for the next meeting, so we can talk about something that might not make sense. coming out of this chapter. So don't always wait for the lectures and then read. The best thing that you can do is work on the chapter before I talk about it, so you guys can bring in questions that might have not made sense in any one of the chapters. Okay? But anyway, I'll see you guys next time, and happy computing. Bye.